In this clip, I want to teach you one of the most common ways to secure the data plane, also referred to as a forwarding plane, on a Cisco iOS router. This would be through the use of access control lists, also referred to as ACLs. There are different variants of ACLs, and I will walk you through how to create them. After that, I will let you know the various ways that you can use the different types of ACLs. The first type of ACL is a standard access control list. A standard ACL only matches on parameters of the source traffic, specifically the source IP address. You can either permit the traffic or deny the traffic. There are three different options to define the traffic. You can define the IP address of the network or host, followed by the wildcard mask. You can use a host keyword, which lets the router know that the IP address that follows is for a single host, rather than a network. Finally, you can use the any keyword, which matches on all IP addresses. Let's take a look at an example ACL and talk through some characteristics of access control lists that apply to all ACLs, not just standard ACLs. Here, I've assigned this ACL the number 11. For standard ACLs, the number has to be between 1 and 99, and then that was expanded to 1300 through 1999. This ACL has 4 lines, and each permit and deny statement is being configured in global configuration mode by using the command access-list, and then the number, and then permit or deny, and finally, the source traffic parameters. When traffic is being matched against an ACL, the router will compare the traffic to each entry in the ACL one by one. As soon as a match is found, whatever is defined in the ACL is applied. This can be easily thought of as an if-then statement. In the case of a standard ACL, the if statement matches on the source traffic, and then the then statement is the permit or deny statement. For example, if traffic is sourced from the IP address of 172.20.1.56 and is being matched against this ACL, the router will compare the source traffic to the first line, which is looking for anything in the 192.168.1.0/24 subnet. Since 172.20.1.56 does not fall into that subnet, the router skips this line and looks at the next line. In the second line, I use the host keyword, which means I didn't need to specify the wildcard. The traffic sourced from 172.20.1.56 is compared against this statement, but only traffic sourced from 172.20.1.55 would match this line, so the router would have to move on to the next line. Here, the traffic is compared against this third line. Since 172.20.1.56 does fall within that subnet, this traffic matches this line. Once the traffic is matched, the router will then apply what the line states, and in this case, the then statement says to permit the traffic, so it will be allowed. But let's say that the next traffic that was being evaluated against this ACL was sourced from 172.20.1.55. It wouldn't match the first statement because it doesn't fall within the 192.168.1.0/24 subnet. But this time, it does match the second statement, so then the ACL will look to see what the then statement is for this line. In this case, it will be denied. Even though the third line would permit this traffic, it doesn't matter. Once a match is found, whatever is defined in the then statement is applied, and no more entries are evaluated. A common mistake I see when network engineers are first starting out learning about ACLs is to mistakenly place ACL entries in the incorrect order. For example, here is another ACL. This time, rather than configuring the permit and deny statements in global config, I entered the command IP access-list and then chose the keyword standard since this is a standard ACL, and then chose the number 1350, which again falls into the expanded range for standard ACLs. The contents of this ACL look very similar to the one I just showed you. The only difference is the order between the permit and deny statements. Walking through this ACL with traffic sourced from 172.20.1.55, again, it wouldn't match the first statement, but it does match the second statement. 172.20.1.55 is part of the 172.20.1.0/24 subnet. Since this does match, the router will permit it, since that is what the line says. But that packet will never be matched against the third line, which denies the traffic. So when you are designing ACLs, be aware of this, and make sure to place more specific match statements before less specific match statements. In the case of standard ACLs, this would mean placing host IPs before subnet IPs, and placing smaller subnet networks, such as the /24, before a larger network, such as the /16 network. Lastly, I wanted to talk about the deny any statement at the bottom of this ACL. If a network engineer wanted to deny any traffic that was not specifically permitted earlier in the ACL, they do not need to manually place this deny any statement. This is because all ACLs include a deny statement at the end of the ACL, regardless if the engineer manually places one there or not. Let me say that again. All ACLs have an implicit deny statement at the bottom of the ACL. So this means that if an ACL is being applied on a router and the traffic is not explicitly permitted, it'll be dropped. However, it is common for engineers to place an explicit deny statement at the end of the ACL and then log any traffic that matches it. For any traffic that does match this deny statement, a syslog entry will be created. This can be useful for engineers to see if there's any traffic that they have left out of the ACL that should have been permitted, or maybe they don't want to allow any more traffic, but they just want to get a baseline of the type of traffic that is traversing through the router. I did want to state that generating a large amount of syslogs can use a high amount of system resources, so Cisco recommends to use the log keyword sparingly. However, a standard ACL isn't always the best use case for identifying traffic that matches an ACL. It is a very simple type of ACL and only matches against source IP addresses. To be able to match in more information, we need to talk about extended ACLs, which we will do so in the next clip.